So we were discussing arrays. If you remember, if you recall the last time when we had a session, we were discussing our arrays concepts, and we discussed these classes, right? These classes which I've created for various concepts. Okay, and these concepts which we have, I think we did till class test 7, right? And we discussed about how we can iterate, through these for loops. So we have nested for loops and different combinations basically to achieve different objectives. So here this was about sorting an array. Okay, this was about sorting an array, and I don't know how many of you have gone through that visualization thing. It's really fun to do. I displayed. I mean, you can just Google on various sorting algorithms and visualization of sorting algorithms, and you will get something. So it really is something which interviewers sometimes ask. Even the complexities, tell the complexity of. So there are basically two things: search algorithms and sorting algorithms, and all of both of them usually deals with a data structure, and the basic data structure which we have is in arrays. That's the reason I'm bringing this topic up, right? So again, just go through it, and maybe I'll just show you for the people who did not join that time. Visualize sorting algorithms. It's really good in order to understand how things are happening. Okay, so different ways. See, this is a different link this time, right? There are different types of sorting algorithms. I'm really not interested in going into details of it. That's really out of our agenda. But it's good to know these things, these concepts. So I'll still recommend you guys to go through these different sorting algorithms: insertion, selection, bubble. So bubble is what we saw, merge, heap, right? And see how they works and visualize. And just if you are kind of motivated enough, just try the examples. You don't have to write it on your own. Just go to internet, find, Google it, you'll get the code, and just try to understand how the code works and how the code is different than the bubble sort, right? And along with that, also go through the complexities. Try to understand complexities. Try to see which sorting is good for what kind of data structure. If the data structure is big enough, then which sorting is good. Data structure is small, then which sorting mechanism, because every different sorting mechanism has different benefits and advantages and disadvantages. So try to go through that. Highly recommended. If you miss it, I can't help it, but I still recommend you guys to do it. Sorting as well as searching is also another thing. Okay, let me not digress much. So we discussed that. Then test 8 was quite simple one, the sum of even numbers. So we discussed that as well. So I think the last class, this is a brief summary, is what we did in the previous sessions, right? And I had these many as well, which we needed to discuss in the last session only, because today was we were supposed to be doing something else, but we kind of spent too much time then. And I really wish to complete arrays at least by today, so that tomorrow I can pick up something new for you to work upon over the gap which we have on Monday. All right, so I'll start with test 1. Okay. Now the previous concept was, by the way, if you have any question, you can stop me in between or even put something in chat. Okay. Now the previous example was wherein we were having a plain arrays and we were only saving integers or strings or chars or doubles. So previous examples which were here, we used it for storing primitives basically, right? So primitive data types are like integer, char, double, float. These are called as primitive data types. So we used it for that. But arrays is not restricted to only saving those data. It can also store user-defined data types. For example, when you create a class A, and if I want to save the object of class A into my arrays, I can do so, right? So this is the example just to demonstrate that. Okay. Then there are subsequent examples which would dig this concept deeper into more details. I'll talk about it. But this example is pretty much very straightforward. So what I'm doing here is so the way I'm declaring it is, because the class name is A, I'm writing A. If you remember, if I wanted to save integers into this array, I would have written int square bracket, excuse me, ref1, right? Something like this. But we want to save a class A, type of A, right? So I am writing here A, right? Then the array represented that this is an array, name of the variable. And then I am putting a new object, okay? Sorry, so this is where I'm initializing it. This is just an initialization declaration of the array. Now in the next step, since once the array is created and is being defined that it's going to store data type of type A, which is anything but your class. Now I am free to insert the values here. So it's already defined that it would contain 5 values, right? And in each of these values elements, which is going to be created 0, and it would be referred as using indexes 0, 1, 2, 3, 4. I'm going to save these new objects. So every time I'm going to say new A, it's going to create a new object for me. So if you know, the way to create an object is A object is equal to new A, right? That's how I create the object, isn't it? So all I'm doing is I have removed this part. All I'm saying is this is equal to new A, and that's the reason I'm writing here like this. Okay, so what I'm doing is every time when all these statements are executed in different cells of this array called as ref, there will be a new object of type A. So again, if you know how object is created, if you know how integers are created, then it's quite simple to understand. But if you did not practice it enough, then it might become a little bit difficult on what's happening here. Okay, so for that purpose, I'm trying to explain that in each of this cell, I'm saving a new object. So previously, I was saving something like this, right? But now I'm saving a complete object like this. Then nothing else, just I've saved it, and I'm just again using a for loop to iterate it and print the value, right? Now something to note here is something which is interesting is this. Okay, now can anyone tell me what is this? So this is the output basically. When I run this is what I'm going to get. So what I'm asking is, what is this? What are these values?
Address location.
No, I didn't quite catch you. Can you come again?
Address location.
Address location.
Yes.
Your voice actually is breaking. Okay, you can put in chat maybe. Address. Okay, someone is saying, Apurva is saying address. Address, and I'm ignoring Purnima because she's advanced student, she would know. So everyone is saying it's an address. Okay, right. So this is not really an address. This is called as Hashcode. Okay, so every class or every object when it gets created is assigned a Hashcode, and not go into much deeper in the concept, because we have to cover this as a part of separate session called as object class. So we'll talk about this in the object class, but this is not really an address. This is called as Hashcode, like the numeric representation of the object, integer representation of the object. How it comes is that maybe I'll try to explain today. I don't know how much you're going to get, but it's important concept to understand. Maybe in the next example, I'll talk about it in detail. Okay, so this is the point is because I'm doing using new keyword, every time I'm putting in data, what's happening is every time I'm going to say new, a new object is created, and for that object, there will be a new hash code associated. So there will be only one object with this hash code. There cannot be two objects with the same hash code, right? So this is how basically the representation of an object looks like. How it comes, how we can get it, that we'll talk about it. Now this is just printing, so nothing more to discuss in this particular Java class. Now I'll go to next one, test 2. Now there's something more interesting happening here. Okay. Okay, so I'll again leave it to you to explain me what's happening here. So this is a class B. This is a class B. Okay, and this is the method here. So can anyone tell me what's happening? What is this? What is peculiar about this? What is different about this class? Any guess? Wild guess? So I'm saying wild guess means, I mean, you can say anything. You can say Shah Rukh Khan as well. I mean, I won't mind. So, but say something. Convert to string. Okay. Convert to string. Okay. What else? Okay. I got one answer, convert to string. Can anyone wishes to say something? I mean, anything would do. Function declared. Okay. Function declared. Okay. Return string. Return string. Okay. Yeah. Yeah. Good observations. Yes. True. Those all are true. Okay. Cool. So this is really not today's lecture scope, but I will still try to explain something. Okay. Um, so how to do it? So let me maybe create a separate class. And you all have noticed this, this thing. Let me just show you. Temp1, I'm creating class temp1. And this temp1, I am putting a method public void method1. Okay. Now let's say I'm in this this class and I want to create an object of method1. Sorry, temp1. So how to create the object of temp1? I'll simply say temp1 temp, name of the variable, new temp1. That's it, right? Then I want to access the method, right? I want to access the method. That means whatever method we have here, I want to call it or trigger it. So how to do it? First, we're going to create the object of it. And then I'll simply say temp1 dot. So the moment I do a temp1 temp dot, I get to see the method here. But I don't want to focus on this. I want to focus on other methods which we see here. Now, these are not the methods which I created, right? And ideally what I should see as a part of this list is the methods which are declared, methods which are defined in this class, temp1. Now in temp1, if I go inside temp1, I see only one object. Sorry, one method, only one method available, right? So ideally, technically, I should see only method one here. I should see only method one. So why the hell I'm seeing all of these? Wait, 3 waits, 1 string, something like that. Now again, an open question for you guys. Can anyone tell me why do I see all of this? Any guesses? People who have some idea about how Java works, they might know. Predefined methods in Java, methods of object class. Inbuilt method, okay. Right, so I like the answer of which Kavita gave. So methods of object class. Now you can say inbuilt methods, yeah, yes, you can say that. But methods, so Vipul said inbuilt methods. So method really can't survive standalone. They have to have their presence inside a class, right? And that class is actually object class, right? So we have a class called as object class in Java, which is kind of the parent of all, like Adam and Eve kind of thing. Okay. So this object class is like an Adam, and every single class which you see in Java is a child of that by default. So you don't have to say like extends object. You don't say this extend object. You don't say this because this is by default is there. If you don't do this, imagine this is there, and it's the object class in which you're going to see these methods. Okay, so it is the object class which has these methods present. Okay, and that's why you see so many methods. So how many are there? Equals, hashcode, toString, right? Wait, few waits. So I'm going to focus on this hashcode and toString part today. Okay. Now, so if I remove this example now, so the thing is, if I don't have, so previously I didn't had anything defined in the class A, nothing was it was a plain class, right? But when I was simply kind of printing it, I was just saying ref I, that means I'm printing it. So what was happening, automatically toString method was getting called and it was returning the hash code of it, right? So if you want to get a hash code of a class, you can simply say dot hash code. So it will give you a hash code. If you don't just explicitly mention it, it will nonetheless will print it. It will just print the hash code. Okay. But what we don't want is to print the hash code. Sometimes it so happens that you don't want to print the hash codes. You want to print some sensible information to the, to the user who is using it, right? So in this case here, this is what I'm doing. So what I did, because I know when I try to print something, toString method is actually being triggered. That I already know, right? If I just try to print the object, toString method is triggered. So what I'm doing here is, and this toString is actually defined where in the object class, and I want to change the behavior of this object class. So what I do is I kind of define the same here signature of the same method signature I will define in the class B, and this will effectively override. This is your override symbol here. Excuse me. This overrides, as you see here, overrides java.lang.object.toString, right? So this method has overridden the parent method. Okay, and that's the reason when we attempt to print this, basically this object here, when we attempt to do this, it will not print you the hash code. Instead, it will print you the information here, which is right now it's returned as B class object. So every time you return it, however, all the objects are different, because if you see here, in the previous example, I was just manually doing it, but in this case, I am actually using a for loop to insert the value. So every time the loop will go, it will store the new object inside this. Every time we do this, it will store the new object, right? So this loop will actually save all the new objects of B inside this reference variable, sorry, this array. And then we are kind of iterating it again to fetch the value. So here I'm simply printing ref I. So this is how I'm fetching the values, fetching the array. And this will actually call toString. Now, if this were not here, it would have called toString method present inside the object, and that would have returned the hash code. But that's not the case here. I have overridden this. So in this case, it is only returning me B class object, right? But what if you want to identify this uniquely? Then what you can simply do is you can say super dot toString, and you can associate it like this. So what will happen now? Here it will first call toString of the super class. Now, who is a super class here? Object lang object. Sorry, Java lang object. This is super class. So what will happen? It will call the toString of the super class, which will in turn return me the hash code. Then it will attach this with the B class object. You see here, so this time I'm getting the hash code as well as I'm also getting the customized message which I want to put here. Okay, now let me, since we are on this topic, let me also explain something about this toString. Now there is a code or a standard, right? Or some criteria on which the reviewer can check your code for faults, right? Now the thing is, whenever you create a class, now there is a standard there, right? And a standard way of creating a class. And so to start with, the name should be right, the methods and all right, return types, and it should not, members should not be public, they should be private. All those things are there. But there's one more important concept present there, which is every class you're going to create, no matter what class you're going to create, it should always have a toString overridden, and it should return something sensible. Okay, so now onwards, you should also follow this practice. Whenever you go and create a class, you should always override the toString method, because if anyone wishes to make use of toString method, it should return some sensible information about the object and not only the hash code, because hash code doesn't make any sense. I think if you are advanced student, and if I think batch 8 people are also here, I think if you have used hash maps and array list and all, if you do a hash map dot toString or an array list dot toString, you will get some sensible information. Okay, because the toString there is kind of implemented. They have overridden the toString. You should also always, and cannot be a circumstance, I can't think of any. Of course there are exceptions, but 95%, 98% times you should be overriding the toString method. This is an absolute necessary. I can show you another example to explain you. Now here, if you notice, I have another class called as employee, which is this, right? Now here there are only two members and one constructor. One is employee ID, second is salary. Then I am passing employee ID and salary here, and this is just to save or initialize the value of this, right? Very simple class, no methods other than a constructor, two members and one constructor, just to initialize the values, nothing else. If I go ahead and print the value of employee, right? So if I, instead of this loop, let's say I don't want to use this statement. Instead of this statement, if I print this, that means I'm simply printing the ref variable one after another. So what's going to happen? It's pretty simple example. I'm initializing the array. It should store the employee data type, and then I'm in every element I'm saving. Guys, give me a minute. Right. So this employee which you see here, this is just I'm declaring it, initializing the arrays, and in subsequent steps here, I'm just initializing it further. Each of these elements I am putting in my new employees. So in each of these elements, I'm going to see a new object of employee, of course, with the data initialized. So this will be the ID, and this will be salary, is it? Yeah, employee ID and salary. Okay. Now, if I just print this value ref I, if I just print this value ref I, what I'm going to see, if I run this, I'm going to see the hash codes. And this is not giving me any information about what are these employees and what it contains. And this is not a good practice. That's why I'm saying whatever class you're going to create, you create, and you always override the toString method there. So the best way to do here is, so this class here, I did not do it. What I did just for demonstration purposes, I said ref I dot employee ID and ref I dot salary. So all I'm doing is simply printing it. I'm just accessing the employee ID and salary and I'm printing. So in this case, it's printing, right? But that might not be the case every time. Sometimes I just want to get the information about what this object is, or maybe the user of my class, employee class someone created, and whoever is using is the user of the class, right? So there can be two entities here. One is the creator of the class, second is the user of the class. So if you are the creator of the class, you should be implementing or kind of overriding the toString method. Always, always, always. No exceptions. It's a good practice. People sometimes don't do it, but you should do it. So what I can print now in this case, I can say, okay, if someone calls a toString method on an object of this class, it should return the information. What is the information here? Int employee ID and salary, right? So I can just simply say return employee, or simply employee ID, emp ID, and then I should say salary. I think that's it. So what will happen now when I do it? Let's see what happens now. If I have done it correctly, I should see the information. So now if you see, I am actually getting what this is. So Hashcode, that is actually an encrypted kind of stuff. It doesn't make any sense to the person who is using your class. But now if someone triggers and toString on your object, it actually shows what that object is. And if you don't want to reveal this information, that's fine. It's up to you what you wish to. It depends on the class, what you want to send as a part of the toString. Here I just chose to use this. Okay, fair enough, guys. Any doubt, concern here? So this is pretty important concept in Java. Use how to use this object class and this toString. I mean, it's not complicated. It's pretty simple thing, but only thing is the concept. So if you're not very familiar with how inheritance works, and that's the reason I was trying to introduce inheritance in the beginning itself, because this is an inheritance concept, overriding and all, right? Because you don't see this here, extends object, but it's actually here. It's kind of phantomized or kind of ghost inheritance, which you don't see. It's there. Okay. You can go through it. I would still recommend you guys to just do this extends object and just go through it and see what do we have here. Check what do we have. Try to read these Java docs. See how it works. Okay. Then let me go back. Let's go to the next example. Again, again an array, basic simple string arrays. I've added the names here, and I'm just looping it. And every time I loop it, I am actually printing, and I'm converting it to the uppercase. Now, what is uppercase? This is just a string function, and we will be maybe doing this when we are going to talk about string manipulations. Maybe not today, but it's pretty straightforward. And as the name suggests, to uppercase, I mean, whatever array element you are going to have, in this case, it's Akash. So when you apply it to uppercase there, it's going to print everything, convert this into an upper string, and it will print it. That's a simple basic function of it. Okay, this is a wrong output. It should be coming in uppercase. If you want to print this into a lowercase, I simply say to lowercase. So this is a string, so that's why I'm getting all the methods which deals with the string manipulations, and all of this we'll work on it. Maybe tomorrow. If not tomorrow, then maybe on Tuesday. By Tuesday, we should be seeing this, because string manipulation is very crucial for logic and all, because you have to deal with a lot of strings while you code. And because of that, a lot of interview questions as well on strings to judge how is your logic. So if you want to lowercase, do a lowercase. It will print everything and convert everything in a lowercase. Now the next one is yeah. So this actually introduce one extra concept which deals with array. It's not an arrays concept per se, but it surely deals with how you can manage a data structure which you have in array format, right? So that actually, so I don't have to explain all of this because you already know this. You know what I'm doing here. It's converting into the uppercase. So converting to the uppercase and then saving it back into the original array. So this step is about this. So in this case, it's looping, and every time it loops, it converts into the uppercase and saves it back. Okay. Now, the interesting thing to notice here is this particular step, which is arrays.sort. Now for this, I have created another class, which is arrays class usage, right? So it has few most typical usage of how you can use this arrays class. Now this arrays class, if I just simply try to explain this in very simple form, this comes with the collection framework, and this actually is used to manipulate arrays, as name suggests. So it has lot of methods, and all are static methods, and you can simply call these methods and pass in the arguments, and it will just do the job. So you remember we had a sorting example. Where did it go? 7. Yeah, I think this is the one, right? So when you really want to sort, you really don't write this logic. Okay, well, all you do is you just call the user defined methods, which is already available. So Java has already solved a lot of problems for you in past 20 years, I should say, right? Or even more than that. So you really don't have to reinvent the wheel and try to write your own logic and all. This is just to practice your logic, and sometimes you really have to loop through and do something. In that cases, you will have to write such kind of logic, but not in the simple examples, simple situations. You don't have to write these nested fors and all you have to do is to make use of an existing class called as arrays, and you can call a specific method. So when you say arrays.sort and you pass it here, right, it gives you the sorted array, and then you can actually loop it to check it. And then there's I'm going to cover that few of these in the arrays class usage, but to quickly walk this through, this is another method present inside arrays. It is binary search. So if I do a dot, maybe I'll just show it to you here. Binary search. So you can actually search inside your arrays. So it can search it, and it can tell you the position at which it has found it. And if it couldn't find it, it gives you a negative value. So comparison, this equals, mismatches, a lot of things are available. Copy, stream is something which was introduced in Java 8 to filtering purposes. Different stream library available. So this is a question sometimes interview asks, tell me about latest Java 8 features. So stream is one of them, right? Maybe something for later, not today. What else? Okay, sorting is there. Okay, different ways of sorting. And if you notice, all of this has the same name. So this is what we discussed, I think I think last week we discussed this about methods or method overloading, right? So you have the same name, binary search everywhere, but different arguments. So this gives Java an understanding that these methods are different, and they calls the different method based on what you have passed as an argument. So if you have sent a char array, it will go and call the binary search, which has an argument type of char array, right, and char key or something like that. So depending on this, it judges. So this is an example how Java uses method overloading effectively. Okay, so the idea is, when you actually go and work, and if you encounter arrays, if you actually go and work and if you encounter arrays and you have to perform any operation on those arrays, try not to write your own logic. Try to use this arrays class. It has lot of method which could come very handy for you to handle it. This is the takeaway from this. The reason I am introducing this here now is what you did previously just for your logic building, and this is a necessity. If I say write a code for sort, you don't be saying arrays.sort. Interviewer would say get lost, right? Because he's interested in how can you write a logic using two for nested fors and all, right? Something similar to someone asks you to print a pyramid. I mean, there's really no use case, absolutely zero use case in the industry. I mean, why would you go and print a pyramid for application, right? But that still is there because it helps you understanding the logic, and you can implement that kind of logic in more complex problem statements of your application, right? So that's the reason we do it. But when you actually go in the industry and you actually work on an actual project, even when we go and do our project here, when we do create a framework and all, you can still make use of the standard practices of handling arrays. So arrays.sort, arrays.binary search, arrays.compare. I mean, lot of other methods available. And since we're talking about this, we hardly use arrays, right? So arrays you should avoid to use unless it's very really you need to do it, because you really cannot change the size of the arrays, and it really is a very big limitation, right? So if you want to use a data structure, go with the collections framework. Again, that is something which we talk about in the coming days rather. So you should be using array list instead of array. You should be using hash maps, vectors, what else? Different so tree structures, sets, right? So we should be using that based on what circumstances or what kind of data we wish to use. But no, never arrays. But arrays is always good to understand the logic part, and the way array works is pretty basic stuff. I mean, if you have no exposure to Java, then even you have some C C++. Any idea about any programming language? The array is the basic. It is that. So that's the reason I'm starting with this. All right, so I'll go to the next one. Again, here it's simple, sorting something and returning, some searching again. So here this operation is about sorting. So see, the sorting is searching, all of this happening in the two statements. And if you notice in the previous one, there was one for sorting and there was one for searching as well. For searching, we were kind of going through one after another each element and then finding the value, right, using a for loop. But here you can do is to simply do a binary search, and that's it. Now this example is not really about arrays, but the reason it returns an array, that's why I've included this. So how it works is in string. So this is a string, and sometimes you have to manipulate the strings, right? So the different operations available in string class, which would help you to break the strings into various parts, try to find a character in the strings, or try to compare it with other strings. So different things, different methods are available. Right now, there's a special method which I've used here, which is called a split. Now, how it works is it takes a regex, which is regular expression, and if you don't understand this, don't worry. Just you can understand it as a delimiter. Means I'm trying to split this based on a specific character present inside here. Not only character, a complete string you can pass here, which would match, and it would divide the string based on that. So right now, if you notice, I have given a space. That means what will happen? This string will be divided in spaces. So maybe the best way to do is to see debug. I'll just simply put a debug point, right click. I'll say debug as Java application, and it will stop here. Switch. Okay, so now what I wish to validate, what I wish to see, watch, basically I should be watching RV. So we live in Earth is the RV. Then I should say, okay, what will happen if rv.split is executed? What will happen if I just do this? So now if you notice, I'm getting an array. So this statement, rv.split has splitted this string in, divided across this space, and it returned me everything in an array format. That's where you have to use array. I mean, you don't have any choice because it returns an array. I mean, you can convert this later into an array list, but originally it would return an array, right? So we live in Earth. This is 0th element. This is first element, second element, third element. And it's not important, but if you can use this for, so now if you put something else here, so in this case I have entered L, so it has split it into two arrays. So one is what was coming here, and second was what was coming after this. If I split this using an I, it's giving me how many? So it will, first entry will have this, second will have this much, third will have this much. That's what it is giving me. 0th element, first element, second element, three elements of this array. So that's how basically split works. We're going to see more often. This is a very useful method, and you have to make use of it a lot while you actually code and when you actually do something. Even in the interview questions, you get lot of interview questions on the string. They will give you a string, they will give you another string, they will say try to find this much which is coming here into the second string. So you have to make use of caret, code, split, a lot of things you can make use of there. So in this case, the only reason I put this is to explain you that it returns an array, and I can simply use a for each loop here, enhanced for, to walk or kind of iterate these elements here. Okay, I hope you understood this. If not, then let me know. I'll try to explain this again. Okay, so same thing here, but a little bit different. So I will not consider this example because this is really more going towards more string operation. So char add is a string operation. So I'll not go there. Maybe just try to explain quickly that I'm just first splitting it. So in the first element, I will see this, second element, I will see this, third element, I will see this, and maybe it doesn't harm to show you in a debug format, because we almost has reached what I wanted to cover today. Okay, so RV, we have customer relation manager, then RV dot split. This is a ref variable, so I will simply do this. This is what? This is an array, and this gives me customer relationship management because I have split this based on spaces. Now there is another variable called as A. The value is empty, right? Or not empty really. A space is there. Space is considered as a char value, right? And then what I'm doing here is I'm just merging this, right? So I'm saying ref 0 char add 0. If I just add this here, it will give me a C. This will give me a C. Let me remove some unnecessary information here. You might get confused. Right. So when I say ref 0 caret, it's giving me C. Why? Because caret actually gives you you can pass in the index, and based on the index, it will give you the char located in that index. So 0 caret of customer 0 is C. Char at of 1 of this customer is U. So if I say 3, what's there in the 3? So in the 3 we have T. Why? Because C is 0, 1, 2, and 3. That's how caret works. So if you don't worry, we're going to talk about this. This is, like, as I said, string manipulation operation. So don't be afraid too much if you didn't get it. But if you did get it, try this. Okay. Test 9. This was a last one in my agenda today. Same thing which we are doing here. The same thing I'm trying to do with this with the for loop. Nothing else. So every time this got split, I'm just iterating the array. Every time I get the element, I am actually getting that first value, which is 0, which gives me the C, and it returns this value, CRM ERP. Every first character of every word. This is not plain examples. These are, I should say, actual interview questions. Sometimes they ask you to write this, but I'm giving you a string, and you have to print the first character of each word which you have in the string. So this is how you're going to write it. If you write it, yes, you're selected. If you're not, then bye bye. Right? So that's the reason you have to practice. Don't just I have reiterated this in the past. I'm just saying it again. These are not for demonstration purposes only. These are the actual examples, and you should be trying it out. These are not, I'm not giving them to you as an assignments, but I do expect you guys to try it out on your own system. Solution is readily available. I always tell you where it is. Maybe where did it go? Yeah, here. Right. So I always ask you, you can actually go and see the link which we have. The people, I think there's one new person, so that's the reason I'm showing it again. Java source, you go here and click on this, you will get to see all the code which I write. So whatever code I write is present here, and you actually get to see this here. And just go through it, open one example at a time, and don't hide just see the context of the program. Try to write it on your own, then compare how you have written it. Right? Make note of how the variables are designed, are written, how is the indentation. You have to notice this as well. I'm going to publish a new list of review checklist, which you would let you know how you're going to write your program, because I'm seeing some programs being written in a not so good manner. So you also need to work upon that. So I'm going to just soon enough publish that review checklist, which you need to go through first before you submit the assignment. Okay, what else? I think so. This brings me to the end of what I wanted to cover today. I wanted to cover strings also today, but I don't have enough energy left to explain that. Okay, so I will close the session. I will not continue with this unless you have something to ask.